As AI agents move from experiments into production, governance can't rely on manual review. In this module, we'll apply FinOps principles as automated guardrails, helping control cost, quality, safety, and reliability across build, deploy, and runtime. To connect the journey so far, we began with cost behavior and FinOps trade-offs, then moved into measuring quality and value. From there, we added visibility through tagging, dashboards, and reporting. Now, with optimization and governance foundations in place, we're ready to turn those practices into policy as code guardrails. Agentic AI changes the governance problem. Costs are no longer driven only by planned infrastructure choices. They can emerge from autonomous decisions: which model an agent selects, which tools it calls, how much context it retrieves, and how often it retrieves. Manual reviews arrive too late for this kind of behavior. Policy as code turns FinOps intent into executable rules that run at decision time, so limits, approvals, routing, tagging, and risk controls are applied consistently across teams, environments, and providers. Guardrails are best understood as a control plane, not a final review gate. They travel with the AI system from design through build, testing, deployment, and live monitoring. At each stage, policies can allow, warn, or block based on cost, quality, safety, security, compliance, and operational risk. Enforcement happens in the systems teams already use, such as CI/CD pipelines, API gateways, model routers, orchestration layers, and observability tools. The goal is safe, cost-aware scaling that teams can repeat. Policy as code depends on 4 connected pieces. First, the system needs trustworthy inputs: tags, model metadata, request context, user identity, environment, cost data, evaluation results, and risk classification. Rules translate those signals into conditions, such as which models are allowed, what quality threshold is required, or when escalation is needed. Actions make the policy real by allowing, denying, warning, throttling, routing, quarantining, or requiring approval. Evidence then records every decision, version, test, and exception, making enforcement auditable and defensible. Cost guardrails move control from a monthly finance review into real-time operations. Budget thresholds can warn teams early, then throttle, or require approval as spend approaches limits. Per-request ceilings prevent one oversized prompt, large context window, or tool loop from creating a surprise bill. Token and rate limits can apply by user, team, application, agent, workflow, model, or tenant. Anomaly detection adds another layer by reacting to sudden spikes in spend, volume, latency, or tokens. Together, these controls make experimentation safer, more predictable, and more accountable. Effective cost policy is usually a graduated response, not a hard stop everywhere. Start by observing spend patterns and notifying owners early. If usage continues to rise, require approval from the right accountable person. Throttling or blocking should come later, and only for clear waste or unacceptable risk. Thresholds also need to vary by environment. Development can be tighter, staging can reflect test cycles, and production should account for customer impact and system criticality. Exception paths keep governance practical for experiments, executive demos, incidents, and high-priority customers. Quality gates make deployment a controlled decision instead of a hopeful handoff. Every code, prompt, model, retrieval, or tool change should prove it still behaves correctly before moving forward. Regression tests catch broken known behaviors. Safety checks look for harmful responses, policy violations, data leakage, and risky tool use. Performance tests confirm latency stays acceptable, while task success scores show whether the agent can still complete real workflows. When gates fail, the change goes back for fixes. When they pass, promotion becomes evidence-based, repeatable, and auditable. For agentic systems, quality cannot be reduced to one score. The agent makes probabilistic decisions across multiple steps, so thresholds should cover each dimension that matters: accuracy, groundedness, task completion, safe refusals, latency, and regression performance. Those thresholds should map to real workflows, such as resolving a support case or generating usable code. Evaluate both individual responses and the full trajectory, including tool calls and handoffs. For high-risk, low-confidence, or ambiguous cases, define a clear human review rule before production. A promotion matrix turns evaluation results into a release decision. If critical checks pass, the model or change can move forward automatically. If results are mostly healthy but show small regressions, a limited rollout or canary may be safer than full production. If safety, quality, or latency crosses a hard threshold, the release stops. The key is traceability. Record the AVIL, dataset, model, prompt, and policy versions so the decision can be explained later. Runtime enforcement is where governance becomes active. As the agent runs, important choices are checked before they happen. Which model it can use, what data it can retrieve, which tools it can call, and whether an action is read-only or allowed to change something. The decision should consider identity, tenant, sensitivity, purpose, environment, and risk tier. For higher risk workflows, the system can require approval, add logging, or force escalation. The principle is simple. Don't leave controls in policy documents. Put them directly in the execution path. Permission policies keep agentic systems from becoming open-ended spend or risk engines. For models, define which workloads may use expensive or sensitive capabilities and when approval is required. For tools, separate read access from actions that write data, execute code, move money, or delete records. Then make the rules context-aware. User role, data sensitivity, environment, region, and customer tier can all change the right decision. The goal is least privilege. Give the agent only the capability it needs for this task in this context. Escalation rules define how autonomy changes when risk increases. Routine actions can proceed, but warning signs should change the path. Low confidence, high policy risk, unusual cost, or significant customer impact can trigger extra checks. For sensitive workflows, approval should be mandatory, including account closure, payments, medical or legal guidance, and privileged infrastructure changes. The goal is to make risk visible, route decisions to the right authority, and preserve evidence for audits, incidents, and future policy updates. Guardrails should operate as a continuous process, not a one-time configuration. Start with a small set of high-value policies, cost thresholds, approved model lists, quality gates, and restrictions on sensitive tools. Before blocking anything, test them in dry run mode against shadow traffic and historical logs. Then deploy policies where decisions actually happen. CI/CD, model routing, API gateways, agent orchestration, and monitoring. At runtime, enforce consistently and capture exceptions. Over time, use cost trends, quality results, incidents, and business feedback to tune thresholds and improve the next policy cycle. The main takeaway is that agentic FinOps governance works when policy becomes executable. Cost guardrails manage spend automatically. Quality gates keep weak or unsafe changes out of production. Runtime controls shape what agents can access, use, and do in real time. Next, we'll focus on the operating model and improvement practices that keep these controls effective as needs evolve.